Imagine holding out your hand. Right now, trillions of invisible particles are passing through it every second, without you feeling a thing. These are neutrinos, often called ghost particles, because they barely interact with anything. They race through space, through planets, even through you, as if nothing is there. But their story is anything but ordinary. A particle unlike any other. Neutrinos are subatomic particles, meaning they're smaller than atoms. Unlike protons and neutrons, which make up the nucleus of an atom, neutrinos don't have an electric charge. This makes them nearly impossible to detect since they don't interact with electromagnetic forces. Scientists first theorized their existence in the 1930s when they noticed something strange about radioactive decay. Energy was missing. Wolfgang Pauli, a physicist, proposed that an unknown particle was carrying away the missing energy. Decades later, neutrinos were finally detected. Why are neutrinos so hard to catch? Neutrinos are like shadows moving through a crowded room without touching anyone. They only interact through the weak nuclear force and gravity, making their detection a challenge. Even though trillions pass through Earth every second, they rarely collide with atoms. To catch a few, scientists build enormous underground detectors filled with tons of water or ice, hoping that, just once in a while, a neutrino will interact with an atom and leave a trace. Where do neutrinos come from? Neutrinos are born in extreme environments. The sun produces them in massive amounts through nuclear reactions. Every time a star explodes in a supernova, a burst of neutrinos is released. Even the Big Bang, the event that started the universe, left behind a sea of ancient neutrinos still traveling through space today. Some come from nuclear reactors on Earth, while others originate from cosmic rays colliding with our atmosphere. The mystery of their mass. For decades, scientists believed neutrinos were massless, but experiments in the late 1990s proved otherwise. Not only do neutrinos have mass, but they also change form as they travel. There are three types: electron, muon, and tau neutrinos, and they constantly shift between these states. This discovery led to a Nobel Prize in physics and opened new questions. How much do neutrinos weigh? Why are they so light compared to other particles? No one knows for sure. Why do neutrinos matter? Even though they seem ghostly and insignificant, neutrinos could hold the key to some of the biggest mysteries in physics. They might help explain why the universe is made of matter instead of antimatter. Their behavior could offer clues about dark matter, the unseen substance that makes up most of the universe. Some theories even suggest that neutrinos played a role in shaping the cosmos after the Big Bang. The future of neutrino research. Scientists are building larger and more sensitive detectors to study neutrinos in greater detail. Projects like the Deep Underground Neutrino Experiment, also known as DUNE, in the US and the Hyper-Kamiokande in Japan aim to unlock more secrets about these elusive particles. With each breakthrough, we move closer to understanding the universe's hidden forces. A universe of possibilities. Neutrinos remind us that the universe is still full of mysteries. They pass through us unnoticed, yet they might hold answers to questions we haven't even thought to ask. Every discovery brings new surprises, proving that sometimes the smallest things can have the biggest impact.